Ask my instructor 11.3.36. Find the area of the region inside the inner loop of the limison r equals 3 plus 6 cosine theta. We know the general shape of a limison, and we know that not all of them loop. But we are told that our limison has an inner loop, and so when we go to graph it, we need to be on the lookout for it. I do recommend the methods of the previous section. I would like to do it a little bit differently in order to just focus on a couple of issues. Looking at theta running between 0 and pi over 2. So I'm looking at theta being in the first quadrant. My radius starts at 9 and decreases until I get to a value of 3. So starting at 0, my radius is 9, and moving from 0 to pi over 2, my radius decreases to a value of 3. I can see that I'm not looping yet, so I'm going to go ahead and look at values of theta in the second quadrant. The first value I'll look at is 2 pi over 3. That's the in the unit circle. That's the first angle I would look at after pi over 2. So starting at 2 pi over 3, I have a radius of 0. After 2 pi over 3, my radius becomes increasingly negative. That puts my points in the fourth quadrant. So even though my angles are in the second quadrant, because the radius is negative, I end up in the fourth quadrant. Then, if I were to draw the complete graph using the methods of the previous section, I would get this limison. Next, we will set up the integral for the area inside the half loop, integrating from 2 pi over 3, where my radius is 0, to the angle of pi, where my radius is 3. Then, where my radius is negative 3. I will then multiply my answer times 2 to get the area of the full inner loop. Now perhaps you're feeling a little uncomfortable right now, and that may be due to this definition that's in the book. The definition in the book requires that the functions be positive, but you may notice if you look at the margin of the book where this definition is, that this requirement of the functions being positive or 0 is only when I'm trying to find the region bounded by two graphs. If I'm finding the region inside just one graph, when only one polar function is involved, the requirement for the function to be positive may be disregarded. And in that case, the definition will read this way. If the region R is bounded by the graph of R equals f of theta, between theta equals alpha and theta equals beta, then the area of R is equal to 1/2 the radius squared, integrating from alpha to beta. So notice that there is no restriction on whether or not R is negative, positive, or 0. All right, so we're going to use this definition to find the area of the half loop. The area of the half loop, I'm using the function 3 plus 6 cosine theta. That is my radius. Alpha is 2 pi over 3, where my inner loop starts. Beta is equal to pi, where my inner loop ends. So setting up my definite integral, I get this. Notice that the area of the entire loop is twice that value. So half loop and full loop. And so I'm just using symmetry to make the problem a little bit easier. Doesn't make a big difference. You can do it the other way if you want. But I'm going to do it this way. So I'm now going to find the area of the full loop, finding this integral. Squaring the binomial I get this. And then, using the power reducing formula for cosine squared theta, I get even closer to finding my definite integral. Next, I'm going to simplify. 36 divided by 2 is 18. Distributing that 18 to 1 and also to cosine 2 theta, I get 18 plus 18 cosine 2 theta. And so I have this definite integral, and I'm ready to combine like terms. 9 plus 18 equals 27. Integrate. The antiderivative of 27 is 27 theta. Antiderivative of cosine is sine. Antiderivative of cosine 2 theta is 1/2 sine 2 theta. Multiply 1/2 times 18 and I get 9. Evaluate. Find the evaluation at pi. Well, sine of pi is equal to 0 and sine of 2 pi is equal to 0. And so the evaluation at pi is 27 pi. Find the evaluation at 2 pi over 3. Sine of 2 pi over 3 is radical 3 over 2. Sine of 4 pi over 3 is negative radical 3 over 2. And so the evaluation at 2 pi over 3 is 18 pi plus 27 times radical 3 over 2. Subtract. Subtracting, we get 9 pi minus 27 times radical 3 over 2. And so the area of the region inside the inner loop of the limacon is 9 pi minus 27 times radical 3 over 2, which is approximately equal to 4.9 square units. You take care. Have a great day.